Welcome to this video on integrating hydrogen as a fuel in the circular economy with a focus on India and global trends. Hydrogen is gaining traction as both a clean energy source and a driver of sustainable industry. Today's video will examine how hydrogen fits into the circular economy principles, how India is advancing its hydrogen strategy, and what the global landscape looks like in case of hydrogen in circular economy. We will also address challenges, leading examples, and the way forward, highlighting the potential for hydrogen to help us build a cleaner, more resource-efficient world. Let us begin with a quick overview of what the circular economy entails. The circular economy is a model that goes beyond the conventional take, make, dispose system. Instead, it prioritizes reusing materials, maximizing production lifespans, and minimizing the waste. This model treats waste as a resource, creating closed loops across industries. Adopting circular principles help us reduce environmental impact and dependency on virgin resources. Hydrogen's ability to facilitate material reuse and turn waste into valuable energy perfectly aligns with these principles. For India, transitioning to circular economy is an essential to achieve sustainable growth, reduce import dependency, and meet climate goals. Hydrogen is a versatile energy carrier that can be produced in several ways. Gray hydrogen is made from fossil fuels and emits carbon dioxide. Blue hydrogen adds carbon capture to reduce emissions. Green hydrogen uses renewable electricity to split water, resulting in near zero emissions, making it most compatible with circular economy. Another type of the hydrogen is golden hydrogen that is naturally present in the Earth's crust, which is produced by various geological processes which we discussed in earlier lecture. Hydrogen power vehicles serve as an industrial feedback or store surplus renewable energy. Importantly, when used, it produces only water vapor, not pollution. The move towards green hydrogen is crucial for industries looking to lower their carbon footprints and transition towards circular, sustainable operations worldwide. Hydrogen is key for decarbonizing sectors that are hard to electrify, such as steel, cement, and chemicals. It closes resources loop by enabling waste-to-energy application, turning industrial byproducts or organic waste into useful fuel. Hydrogen also helps integrate and stabilize renewable energy by acting as storage for surplus power, smoothing supply fluctuations. Its clean combustion means fewer pollutants and improved local air quality. By fostering more efficient resource use and reducing greenhouse gas emission, hydrogen advances the goal of circular economy, making energy system more resilient, sustainable, and adaptable to future needs. Hydrogen fits circular principles by enabling the recyclability and long-term maintenance of key technology like fuel cells and electrolyzers. Industrial symbiosis evolves as a companies share byproduct, waste, heat, gases, or even recovered water across facilities, increasing overall efficiency. Hydrogen's unique role as a medium for storing renewable energy ensures that excess power isn't wasted but redeployed later when demand is high. These practices drive down overall resource consumption, lower environmental impact, and make industrial processes cleaner. By designing systems of end-of-life recovery and repurposing, we maximize the value extracted from every resource input. India is advancing a bold circular economy agenda to address its rapid urbanization, industrial growth, and resource constraints. The government's vision emphasizes optimizing resources, extending product life cycle, and embracing clean technology like hydrogen. Policies and funding targets resource efficiency and efficient emission reductions across manufacturing, agriculture, transportation, and waste management. Public-private partnerships and cluster development are encouraged to stimulate innovation and scale new circular models. By integrating hydrogen into this framework, India hopes to leapfrog towards a greener industrial base, enhancing energy security and becoming a leader in sustainable economic transformation. Launched in 2022, the National Green Hydrogen Mission, which we discussed in earlier lectures, aims to establish India as a formidable producer and exporter of green hydrogen. The target 5 million metric tons per year by 2030, supported by investments in research and development, technology pilots, and infrastructure. Focus sectors include refining, steel, and fertilizers, where hydrogen can be sharply reduce emissions. The mission backs innovative startups and partnership, creating opportunities in manufacturing, jobs, and export. By investing in green hydrogen, India is tackling climate goals and positioning itself to support global supply chain as demand for low carbon fuel grows. India is developing strategic hydrogen hubs in locations like Madura, Gopalpur, close to abundant renewable energy sources and export ports. These clusters bring together producers, large industrial users, and export infrastructure. They are integrated with heavy industries such as steel and fertilizers to directly replace fossil-based processes with hydrogen-fueled alternatives. Clustering enables economies of scale, streamlined logistics, and shared facilities for storage and transport. These hubs don't just serve as domestic needs, they are designed for international exports and making India as a potential hydrogen supplier for Europe, Asia, and beyond. Circularity isn't just about recycling waste, it is about closing every possible loop. Industries in India are piloting projects where carbon dioxide emissions are captured and combined with green hydrogen to create methanol and eco-friendly polymers, new products from what was once waste. Water is another concern. Advanced recycling systems are being adopted to ensure that electrolyzers, which need pure water, don't increase pressure on already scarce resources. These efforts illustrate practical ways to embed hydrogen into truly circular industrial systems, supporting sustainability by design rather than an afterthought. Building circular hydrogen infrastructure means thinking beyond initial deployment. Electrolyzers and fuel cells are designed for modular assembly, easy maintenance, and eventual recycling. Innovative recovery methods such as hydrometallurgy and advanced sound wave technology help reclaim precious metals like platinum at high rate. Infrastructure is mapped to existing logistics, ensuring quick distribution and minimal losses across the supply chain. By planning upgrades, repairability, and reuse state at the start, India can ensure the life cycle benefits of hydrogen technologies align with the broader circular economy goals. India's hydrogen hubs serve dual functions. Domestically, they anchor power and industrial sectors to clean hydrogen supply, supplying steelworks, refineries, and fertilizer plants. Strategically located near ports like Mundra and rail corridors, these hubs can efficiently move hydrogen to international markets, answering the growing demand from Europe and East Asia. Comprehensive logistics planning ensure minimal waste and high economic value. India's ability to export clean hydrogen not only supports its economy and job creation but also helps to decarbonize supply chain globally, further reinforcing circular tenets. Despite strong momentum, India faces significant hurdles. Green hydrogen production is still costly due to technologies and infrastructure requirement. Electrolysis requires pure water, raising sustainability questions in water-stressed regions. So, efficient recycling is vital. Investments must be scaled up rapidly and private sector involvement is needed for innovation. Policy support, cleaner regulation, and public-private partnership will determine how soon green hydrogen becomes cost competitive. Overcoming these challenges is a key for India to solidify its place as an global hydrogen leader and fulfill broader sustainable development goals. Globally, green hydrogen is advancing as a nation push for zero-emission targets. Leading players include the European Union, Japan, and China, who invest in integrated hydrogen and clean industry clusters. The focus extended beyond energy to mobility, chemicals, and even aviation. Trendsetters apply circularity through shared infrastructure by project exchange and waste-to-hydrogen plants. Policy supports, financing innovation, and collaborative research are common themes. These global trends offer a case study partnership opportunities for India, reinforcing interconnectedness of the hydrogen transition in the world. Real-world industrial symbiosis shows that power of hydrogen in circular hydrogen systems. In Denmark's Kalundborg cluster, hydrogen and other byproducts are efficiently shared between power plants, chemical factories, and municipal utilities, resulting in resource saving and reducing emissions. Japanese and Korean cities turn municipal waste into hydrogen, powering the fuel cell and buses and grid supply with leftover water heat looping back to the other users. These examples demonstrate scalable, profitable, and truly circular use of hydrogen, inspiring similar initiatives in India and beyond. Innovative technologies now allow conversion of waste like crop residue, food scraps, and plastic into hydrogen via gasification or fermentation. The resulting hydrogen then powers fuel cells for electricity, producing clean energy while drastically reducing landfill and associated pollution. Municipalities around the world are integrating waste to energy with microgrids, enhancing resilience and supporting local economies. These systems exemplify the circular economy in action, using one sector's waste in another sector's resource, and in the process closing loop and cutting carbon emissions. A truly circular hydrogen economy must recover and recycle high-value materials, fuel cells, and electrolyzers. For instance, use platinum and other rare metals. New physical and chemical recovery processes, some using ultrasound waves, now achieve over 90% recovery efficiency. Product designs increasingly allow easy disassembly and reuse of parts. Global standards are being deployed for recycling logistics and certification, ensuring that hydrogen technologies themselves are part of value loop. This commitment to recyclability reduces supply risk and improves environmental impacts. Adopting hydrogen in a circular model brings broad benefits. It strengthens national energy security, reducing reliance on fossil imports, and makes power system more resilient to supply shocks. Flexible hydrogen storage smooths out intermittent renewable generation, helping balance supply and demand. The circular approach also fosters innovation, new materials, better recycling methods, and updated industrial processes. Collectively, this shift drives emission down, lowers cost over the time, and supports a new era of environmentally sustainable industry. There are major global obstacles to overcome. Grey hydrogen produced from fossil fuels still dominates due to lower cost, making the transition to green hydrogen challenging. Securing closed and predictable supply chain for key material like platinum requires international cooperation and recycling and governance. Developing safe, efficient cross-border standards for hydrogen and transport and storage is another hurdle. Coordinated investment, policy alignment, and technology innovation will be needed to unlock the full potential of circular hydrogen economy worldwide. The journey to a circular hydrogen economy requires focused research into more efficient and affordable electrolysis methods, new waste-to-energy technologies, and advanced recycling systems. Cost industry and global partnership can speed up technology learning and deployment. Governments and institutions should update regulations to encourage circular design, material recovery, and knowledge sharing. As India scales into hydrogen sector, learning from global leaders and fostering open collaboration will ensure shared success, accelerating the transition for everyone. In conclusion, hydrogen holds immense potential promise as a catalyst for a circular economy in India and worldwide. From powering clean industry to enabling waste conversion and resource recovery, it is shaping a more sustainable, resilient future. Achieving this vision depends upon upfront investment, circular product design, robust recycling system, and supportive policy framework. With coordinated innovation, partnership, and commitment, hydrogen will enable industries and communities to transition rapidly to cleaner, high-efficient, resource-looped economy. Thank you for joining this lecture on circular economy and the hydrogen. Thank you.